In this experiment, we're going to have two goals. We're going to determine the unknown concentration of an acid, and then we're going to determine the Ka of that weak acid. We're going to start by standardizing the titrant that we're going to use to do the chemical analysis. We're going to use an approximately 0.1 molar concentration of sodium hydroxide. So to standardize sodium hydroxide, we commonly use an acid called KHP that's available in a solid form. There's KHP with its molecular weight. It's been dried and is ready to weigh. To weigh out the KHP then, we're going to be using half-gram samples with this particular lab, and I'm going to use a weighing boat. So I zeroed out my balance. I'll put the boat on and zero that out as well. To wait for the mass to come up. Then we will zero it out. T-A-R-E, tear it out is what we say. We're going to use the KHP. And we're going to measure out a half a gram sample. Note the molecular weight. There. Okay, that's pretty good. So once we have our sample weighed, we close the doors and we'll get you a good picture of the mass. Oh, it's wanting to wander a bit. Let's wait for it to stabilize. That's oh geez, come on. Okay, that's pretty good right there. So we'll take that as our mass. Now what I'll do is I'm going to put that into my number 1 Erlenmeyer flask because I'm going to titrate that with the standard that I mixed up already. So I'll put that into the Erlenmeyer. And something that's a good idea if you're trying to do very careful work is to make sure that all the KHP went into the Erlenmeyer. So in order to do that, what I'll do is I'll also rinse, since I'm going to be dissolving in water anyway, I'll rinse the boat with some distilled water and make sure that it all goes into the Erlenmeyer flask and it will dissolve up. Likewise, I'm going to weigh out 2 more portions of a half a gram of the KHP and put them into 2 more Erlenmeyer flasks. Prepared a solution of 0.1 molar sodium hydroxide from a 6 molar solution, and this is 500 milliliters. So I prepared that off camera. I also rinsed the burette with the solution 3 times after cleaning it, of course, first with distilled water. So now I'm going to go ahead and fill the burette so that we're ready to begin the first part of the experiment in terms of quantifying or goals of quantification, and that's to determine the concentration of our unknown acid. So, using the funnel at the top, I will pour my solution in. Until it gets towards the top. Doesn't have to be 0 exactly. I don't need to obsess over that because I'll read the value when I get there. Okay. So remembering to take the funnel out before I do any measurements. I then have to drain a little in order to make sure that the tip is full of sodium hydroxide. So I'll use a little waste beaker to do that, and making sure that the tip is completely full and that there's no bubbles that can be seen in the tip. The solution is just running through clearly. So at that point, we're ready to read our initial volume. And I will let you do that. And there are your numbers. There. And I'll slide it a little bit so you can see the gradations. And against the whiteboard is pretty good, I think, in terms of reading that. Get you focused. And then if you need a little bit more help, I'll just put my hand back there so you can read it. And that's your initial volume for the first titration. This is a phenolpthalein endpoint titration. I've already prepared my first Erlenmeyer flask. It has some water that I added, about 40 milliliters of water, in order to give it a little more good volume in here so that I can see the endpoint when it appears. And then I added the phenolpthalein. Now I'm going to do something a little bit new. I'm going to use a magnetic stir bar in this solution. So a magnetic stir bar is just a little magnet like this. Put it into the solution carefully so we don't want to splash too much. If we feel like we've splashed, you can always rinse the sides down a little, make sure everything's down where it's supposed to be. And then a hot plate comes with two things. It has heat and stir. You center it on the hot plate. You'll notice that there's a little magnet. You see how the magnet stays towards the center of the hot plate? So you center it so the magnet's in the middle, and then if you turn the stir, it oscillates the magnetic field so that it stirs for you, so you don't have to keep swirling, which is kind of nice. The only aspect of this that gets a little bit hard is that you have to have the burette up high enough to be able to dispense the liquid into the Erlenmeyer flask properly. You move this, adjust this a little bit so it's just directly over, and then I'll lower it so that we can avoid excess splashing when we add the reagents in. Now I already calculated. You can stir a little bit more vigorously. This is really laconic. There we go. I already calculated about how much volume the titration should take, so I'm going to add an amount that's shy of that volume because I don't really know what the concentration of the sodium hydroxide is, but aggressive enough that it'll save me some time. So here comes our initial volume. I'll stop at a value that I've already decided would be appropriate to stop for my sample number 1. So we're getting there pretty rapidly, actually. So I'm going to go ahead and cut it off here. And you see that the red goes away. Now, just in case there was some splashing while I was doing that, I will go ahead and rinse down the sides to make sure that all the reactants are down in the Erlenmeyer where they're supposed to be. Now from here, I'll be careful. So I'll add perhaps a drop at a time. Depends on how long that pink lingers. It's actually lingering a little bit, so I want to be a bit careful. And I can adjust it so it adds 1 drop at a time. So if it looks like it's lingering, I can shut it down really quickly and make sure I'm not adding too much. It's looking pretty good. I'm not worried yet. And the nice thing about the hot plate is it has a white surface, so we can see the pink color fairly easily against the surface. That's lingering a little bit, so I might want to be careful and just shut the drops down so they're not automatically going. I have a drop on the tip that I'm going to go ahead and rinse off to go in. It's disappeared fairly rapidly, so I don't think I'm quite, as too close yet, but I'm probably going to go dropwise from here just to make sure that I don't overshoot, because the better this titration goes, the more accurate my chemical analysis will be. You can't do an analysis any better than your standardization of your titrant. So if your titrant concentration is off, the resulting analysis will also be off, which makes sense, right? So I'm just tipping forward, dispensing 1 drop, and tipping back. When I do that, that does leave a hanging drop still on the end, so I want to be a little bit careful Here's a hanging drop, so if I rinse that off, then I'm confident I've got everything off. And I'm going to be as close as I can to that equivalence point. I want the end point where I actually decide the reactions over in the lab to be as close as possible to the equivalence point, the point at which the two reactants are stoichiometrically equivalent. That'll make my calculation of concentration that much more accurate. There's a hanging drop, put it in. Whoa, excellent, put 2 drops. Dangerous. And this is nice because I don't have to swirl every time. So I like using these magnetic stir bars for an endpoint, the phenolpthalein endpoint especially, because those are relatively easy to spot. That one lingered a bit. I got a little nervous because that was a little bit more than a drop. So I got to be very careful. So I think I might be getting close. It's hanging. Again, if you want to be careful that you're not adding 2 drops instead of 1, you can hang the drop and then rinse it in. Still not there. Takes a lot of patience. Just the minute you lose your patience, you add too much and you miss that nice endpoint that you want to see. I'm as impatient as anyone, trust me, on that. But I'm trying to be super careful for you guys. It doesn't want to drop in. I'm afraid to just open it up a little bit more because I'm going to put in more than 1 drop, and I don't want to do that. So when it's hanging like that, I just rinse it down, as you've seen me do multiple times already. this close. Okay, getting there. I think that's it. That looks to be it. So you see the nice pale pink color? That took just one little drop. I can turn off the stir. You can see it nice. So let's take a look at our end volume. Here's our ending volume. Let's try and get that up against, again, it depends sometimes on you personally, whether it looks better against the whiteboard or against my hand. I'll show you both ways. So that's against the whiteboard, that's pretty good. And then there's my hand. And hopefully you can get a nice good reading. So that's our final volume reading. Okay, so from there you should be able to calculate the concentration based on one trial. I'll do 2 more trials off camera and show you the initial and final readings for the titrations for those. Now that we're done standardizing the base, we're ready to do our chemical analysis of the acid. So I have a bottle of an unknown weak acid here, and I'm going to analyze it then to see what the concentration is. I'm going to use 10 milliliter samples, and the best way to measure out those samples with an analytical level of accuracy is to use a volumetric pipette. So I have my 10 milliliter volumetric pipette here. See, this is 10, and I'm using my pipette bulb, and I'll put my tip. Now if I have enough reagent, I definitely will want to rinse my pipette with some of the solution that I'm going to be pipetting with, just to make sure that the walls are lined with that solution. And then I'll be ready. If you have enough, it's nice to be able to rinse it 3 times. I'm not sure I'm going to have enough. I want to make sure that I'm able to complete the analysis today and also determine the Ka. So I'm going to go ahead and pipette over my 10 ml sample at this point. So I want to make sure, oh, I got pretty lucky. It looks like the meniscus is right on the line. And I will go ahead and dispense it into the Erlenmeyer flask. Letting it naturally come out by gravity. And of course there's going to be some left in the tip, but if you see anything hanging off the tip, it's customary to just touch the tip to the side of the vessel to make sure that everything that's supposed to come out has come out, and everything that's supposed to stay in will stay in, and there's always just a little liquid left in the tip. It's calibrated to deliver 10 mils, not to contain 10 mils. Now that's a small volume, so I'm going to space that volume out by adding some distilled water in order to help me visualize the endpoint color more easily. Then I'll add the phenolpthalein indicator. You'll see directions telling anywhere from 3 to 5 drops. The exact amount's not critical. Make sure that's ready to go. I'm going to go ahead and use the stir bar again. And I've made sure that the stir bar is completely clean. And because it goes in with a little sploosh, I want to make sure that everything is down at the bottom of the Erlenmeyer flask where it's supposed to be. Now, of course, I have to take an initial reading of the, let's try again. Okay, I think that's pretty good. And bringing it around just to make sure that you can see the lines and where the meniscus is. Okay. Let's commence with the titration then. Because it's an unknown, we don't know where the equivalence point is going to be this time. I have no idea what that concentration is. It could take a lot, it could take a little. So sometimes if we have enough reagent, we'll do one quick titration where we just blast through to the endpoint and we don't attempt to nail it accurately, just to kind of burn up one attempt in order to figure out where the equivalence point is and to speed up our other attempts. I'm not going to do that because, again, as I said, I don't really want to use too much reagent in case I have a missed titration, have to start over. There's only so much in that little bottle, so there might be plenty to do one if you were actually doing this in the lab, but I'm going to be careful on the first shot. So I'm going to go a little bit by feel. I'm not going to just go dropwise from the beginning. I'm going to give it a little squirt and see how it looks. I don't see too much red yet, so I'm just going to continue by squirt. In fact, for this titration, why don't we give you a different viewpoint. You could just look right into the vessel while we're doing that, and maybe that will be a little bit more interesting. The contrast isn't great. But we like to have the white in the background because that helps us see the pink better. And it's not lingering at all, so I'm not really worried about adding the squirts too quickly. So if it starts taking a little bit more time to swish away, then I'll slow down. It's taking a little bit more time. Let's slow down just a tad. Okay, that one's taking a little bit longer, so let's maybe go dropwise now and see how it goes. Slow down for a second. Okay, I'm going to center that a little bit better. And I think I might want to rinse down the sides a bit. Once I've done the first one, the second two that I'll do off camera will go a lot more quickly because I'll know where the equivalence point is supposed to be, especially since I'm using 10 ml samples for each one. It should be really, really, really close to each other. That's it. I should have done the hanging drop because that's a little darker than I would have liked. But you can see it pretty easily. That was one drop. I had a feeling that the drop before might have been it, but it was not, to me it did not look pink. And I was going to try and just hang a drop, which would have given me a nice paler color, but we'll take it. Let's try and get that focused a little bit better for you. And then you can see that that's a 37 there. Back up just a little bit. Okay. So that's where we're at. When I do the next 2 titrations, which I'll do off camera, I will go right down to 35 or 36 milliliters, and it'll go a lot quicker for me. And then I'll give you the pictures of the resulting initial and final volume readings. Now that we've determined the concentration of our weak acid, we're entering the part of the lab where we're determining the Ka of the weak acid. So in order to do that, we're going to construct a titration curve. So we're going to plot the pH versus milliliters of sodium hydroxide added, and that's going to give us information in which we can determine the Ka of the weak acid. We're going to use a pH meter. You'll see this pH meter here. It's stored in a solution that is a set buffer at a pH. This is a pH, of course, of 4.02, and the buffer keeps that at a constant pH value. The pH meter needs ions in order for it to read properly and for its probe, which you can see is made of glass, to function properly. So it doesn't read or function properly if you place it in water. So we also store it in an ionic substance as well in order to keep it conditioned and reading properly. Now we're going to start by reading the pH of our acid. I've already prepared the acid according to the laboratory instructions. I've pipetted 10 milliliters of the acid into this beaker. We're going to use a beaker instead of an Erlenmeyer flask so that we have enough spot in the mouth in order to fit everything that we need. So the pH meter will go in there and we'll read the pH. You should be able to see that. And then hopefully you'll be able to also see the pH as it changes as we do the titration. Now I'm going to give you data for this. We're not going to take all of the readings because it's too difficult to do by video. So I'll just be adding quantities and describing what I'm doing and then giving you a data file later in order to actually process your titration curve. But if you want to know what's going on, of course, you'll watch the video. Now, to make things interesting, I'm going to add some phenolpthalein indicator so that we can also see the color change as we approach the equivalence point, both the color change and the pH change. So we see now that we're at a more acidic environment than we were in the buffer that the pH meter was stored in. So this is just the acid by itself. Now, as we add base, we're supposed to be adding it 1 milliliter at a time, so I'll do that initially. There's 1 milliliter. You'll see that the pH changes to become a little more basic. That makes sense. You're adding some sodium hydroxide. You are neutralizing some of the acid and converting it into its conjugate base. So we know that the weak acid HA plus the hydroxide from the sodium hydroxide produces water plus A minus, where A minus is the conjugate base of our weak acid. So during this part of our titration, we're actually creating a buffer, a solution that contains unneutralized weak acid plus A minus we're converting by neutralizing part of it. And we see that it gradually, but very subtly, the pH does increase. Now if you titrate a strong acid and did the same type of thing, you would see that the pH is even a bit flatter, because in that case, all you're doing is taking H plus and adding hydroxide and producing water. So the pH is only dependent on whichever reagent is in excess. So before the equivalence point, it is only the acid that's in excess. And the only way that the pH changes is the very small concentration changes in the acid itself as it gets neutralized. So this is actually increases the pH at a little bit more abrupt level than than if we saw it with a strong acid. Okay, I'm going to go ahead and add in a quantity that's going to take me closer to the equivalence point, which we've already seen in the previous part of this experiment where the equivalence point is. And the pH meter is going to be a little bit like, ooh, as it tries to keep track with the pH. We're going to let it equilibrate here for a little bit. And I'll get a little bit closer to the equivalence point. And at the equivalence point, what we are supposed to do is to slow down our addition of our base. Let's see what the pH says right now. Oh, so we're about 5 now, so we're still pretty acidic. We're acidic, not strongly acidic. It's definitely gotten more basic. We started at around a 4, and now it's a 5. Well, we started at a 3, I'm sorry. And now it's a 5. So as we get closer to the equivalence point, we're going to see that we're going to get an abrupt change in the pH. Now, the slower we do this, the more gradually we approach the equivalence point. If we're slowing down at the proper spot, the more detail that we'll have in our titration curve, and the better curve you'll get for analysis' sake. So right now we're at pH still a little over 5, so it's still been a pretty gradual change. This guy a little bit, so it's not ringing so closely. The bulb, the glass bulb, is pretty well protected by plastic on each side, so I'm not too concerned that the magnetic stir bar is going to cause a problem and break the bulb. Okay, so I'm getting closer. So at this point, let's see what the pH is. We're at 5.44, so we're approaching 6. So I'm going to slow down a little bit so that you can see. I'm just going to add a little squirt at a time. We can see that the indicator's lingering a little bit more, so we must be getting a little bit more close to the equivalence point. So we want to add it. It says like 0.1 mil at a time. So if you're doing this in the lab, you're just monitoring your burette and making sure that each little squirt does not exceed 0.1 mil. The better you do this, again, the more sharply, or the more detail you'll get in your curve, and it leaves less up to guesswork. You'll get a nice looking curve. So we're still looking. Wait for that pH to come to a nice reading. And try again. I feel like we're close. So each time we would be taking a volume reading along with the pH reading that you're seeing here. Still not. We're a little bit out. And I'm adding it, you see it's not, I'm not going drop-wise. I'm adding just 1/10 of a mil at a time. Actually, I was adding a little bit more. Now I'm going to watch it just a little bit more closely and add it 1/10 of a mil at a time. Hopefully you'll be able to see that jump when it happens. This means I might not nail the endpoint with that nice pale pink color we're used to seeing. I might go past it because I'm not going drop-wise. It's too tedious if you go drop-wise. It's hard to, it's not that important in constructing the curve that you have the endpoint identified exactly perfectly. It is definitely taking a lot longer for that color to dissipate. And here's another one. Now we're we're getting a nice jump. All of a sudden we went from acidic into the basic range. And you see, notice the color in the beaker? So we're definitely past the equivalence point. Now what I recommend to students is to keep taking a few tight readings in here, not to just all of a sudden splash in a bunch if you want to have a really nice looking curve. And look how dark it gets as we go past the equivalence point. And now all of a sudden, bang, it's 10. So even though that color changed, you need to hold off and keep adding by 1/10 of a mil until it stops changing abruptly. Once it seems like it's leveled off with the change, that was a huge change. Then it's wise to take at least 3 more readings a milliliter apart so that you have a really nice looking curve that doesn't have some funky gaps in it. So as I go past a whole mil, you'll see it getting more and more basic, because at this point all of the acids neutralized. We have conjugate base present, there's A- present, but now we're adding excess hydroxide. The excess hydroxide, because it's a strong base, is going to dominate the pH, and now the pH is getting quite basic, as you can see. So you'll want to access the data that I'm going to provide and construct a titration curve based on the information in that data table. But here you can see a visual representation of what the pH versus volume during the titration of a weak acid looks like.